There should be a horizon here. Somewhere, the sky should meet the earth. Instead, the line simply disappears. People seem to walk through the clouds. Mountains hang in midair. For a moment, even the simplest sense of direction begins to slip away. At first glance, it looks like an enormous lake. Except for one problem. For most of the year, there isn't one.
Strange ground.
This is Salar de Uyuni. When rain falls across Bolivia's high plateau, it doesn't need to be deep. A thin layer is enough. Spread across an unusually level surface, that shallow water reflects the sky so clearly that the horizon disappears. Then, almost as quietly as it arrived, the water retreats. What looked like a vast lake becomes something entirely different. A white expanse of salt stretching for about 10,000 square kilometers. The largest continuous salt flat on Earth. So, where did all that salt come from? The first clue isn't the salt. It's the map. Every stream that reaches this basin comes to the same conclusion. The journey ends here. Unlike most rivers, the water has no path to the sea. It collects. Then, under the dry mountain air, it slowly disappears. Not all of it, though. Every flood leaves behind tiny amounts of dissolved minerals. Too little to notice at first, but over thousands of years, those traces begin to add up. Season after season, layer upon layer. Eventually, salt crystals spread across the basin. At first, that seems to explain everything. An ancient lake dried up and left. Beneath the salt, the pattern repeats. Salt, sediment, salt again. It could only have formed one way. Water filled the basin. The climate changed. The lakes shrank. Salt spread across the exposed floor. Later, the water returned, and the cycle began again. This happened more than once. One of the largest ancient lake phases is known today as Paleo Lake Tauca. It covered far more of the Altiplano than the modern Salar. But Tauca wasn't the beginning, and it wasn't the end. Salar de Uyuni wasn't shaped by one disappearing lake. It was shaped by many, each leaving another layer behind. Which raises another question. If every lake left something behind, what else is hidden beneath the salt? Those buried layers preserve more than the history of ancient lakes. They also contain mineral-rich brines. Dissolved within them is one of the world's most sought-after resources, lithium. Not a solid metal, but mixed into underground brines alongside other dissolved minerals. Bolivia holds one of the world's largest identified lithium resources. But finding lithium and producing it are very different things. Separating it from the surrounding minerals is technically difficult. The chemistry is complex. The landscape that concentrated so much lithium over thousands of years also makes it difficult to extract. Sometimes, the same geology that creates an extraordinary place also makes it extraordinarily difficult to use. As demand for rechargeable batteries has grown, attention has turned toward places like Uyuni. Some projects rely on evaporation ponds. Others use newer methods known as direct lithium extraction. Each promises a different approach. Each brings different challenges. How much water is needed? How much energy? What happens to the remaining brine? The answers depend on the technology, the chemistry, and how the basin is managed. The question is no longer whether the lithium is here. It's how it can be recovered responsibly.
From the air, Uyuni can seem empty. On the ground, it isn't. Long before visitors came searching for reflections, people were already building their lives around this landscape. Salt has been harvested here for generations. Across the surrounding Altiplano, communities grow quinoa, raise camelids, welcome travelers, and move across a place they know intimately. Today, lithium brings new opportunities. It also brings difficult decisions about water, consultation, and who benefits from the changes still unfolding. There isn't one answer, only a landscape shared by many different priorities.
When the rains return, the mirror returns with them. Once again, the horizon disappears. It's easy to think that's what makes Salar de Uyuni remarkable. It isn't. The reflection is only the surface. Beneath it lies the memory of ancient lakes, a record of changing climates, one of the world's largest identified lithium resources, and choices that will shape this landscape for decades to come. The question now isn't how Salar de Uyuni became one of the world's strangest places. We know the answer to that. The question is, how do you protect a landscape that the modern world increasingly depends on?
Places like this shouldn't exist, but they do. If you enjoyed this investigation, like the video and subscribe to Strange Ground. And if you're not ready to leave yet, another case is waiting on your screen now. Until next time, stay curious.